Welcome to episode number 4, Ionic Bonding. Now, in the previous episode, we learned about the periodic table and electron dot diagrams. So, let's put those skills to use and draw the electron dot diagrams for sodium and chlorine. So, this is sodium here, sodium, and this is chlorine. These are the symbols for sodium and chlorine. So draw the electron dot diagram for sodium and chlorine. So look back, the periodic table, remember what I taught you last episode, find out how many valence electrons they have, then draw the electron dot diagram. So pause the video now and do that. Okay, so I'll reveal the answers now. Sodium has one valence electron because remember it's part of the alkali metals and it's part of group 1, so it has one valence electron. So you can draw it on any side, but just for the demonstration I'll draw it on this side because it's facing towards the chlorine. But it doesn't really matter. Chlorine has 7 valence electrons. So remember the rules. We do one on each side, then we start to double up. And I'm also gonna double up the sides that are facing away from the sodium. Again, that doesn't really matter, but for this demonstration, I'm just gonna do that. Now, these pairs, they cannot bond, right? They're already paired. So chlorine can't make a bond here, right? Or here, or here, because chlorine has pairs of valence electrons there, right? So they're already pairs, they cannot bond, but what can bond is this single valence electron, right? Now, chlorine has 7 valence electrons, and so it needs one more valence electron to complete the octet rule, so that it can have 8 valence electrons. Sodium, remember, alkali metals want to lose one valence electron because its inner shells are already filled. So its valence shell becomes its inner shell that's already filled, and so then it becomes happy, and it satisfies the octet rule. So what happens? Sodium wants to lose a valence electron, chlorine wants to gain one, right? So what happens? Sodium gives a valence electron to chlorine. And now, how we would represent this type of chemical reaction, or chemical bond more, how we would represent this chemical bond would we would draw Na, and then we would draw chlorine. Now, chlorine now has a full shell of valence electrons, right? Because sodium gave it one. So we draw valence electrons on each side. Now sodium lost a valence electron. So you might think to draw its new valence shell, but for ionic bonds, the element that loses an electron, which is a metal, I'll get into that, but you don't draw the valence shell, so we just leave it like this. So this would be how you represent the bond between sodium and chlorine. But one more thing, you would actually draw sodium with a positive sign and chlorine with a negative sign. Think back to episode number 1, the structure of an atom. Electrons have a negative charge. So if sodium loses an electron, it's going to have a positive charge, and chlorine gains an electron, right? So it has a negative charge, and that's what keeps these two together, right? Positive and negative charges attract towards each other. So now that sodium's positive and chlorine's negative, they stick together. So this is called an ionic bond. And the thing is, ionic bonds only happen between one metal and one non-metal. So sodium is our metal here, right? And chlorine is our non-metal here. So when they bond, they make an ionic bond because it's a metal and non-metal. And this is how you would draw an ionic bond between any elements, right? The element symbols for the metal, you don't draw any valence electrons because it lost valence electrons. But for the non-metal, you draw its new valence electrons, and you also draw the charges. Sodium has a positive charge. This would technically be 1 plus and 1 minus. So, for example, if sodium, let's say in another universe, sodium had 2 valence electrons, and it gave 2 valence electrons to chlorine, which had 6 valence electrons. It would be 2 plus, 2 minus, because now sodium lost 2 electrons, and so it has a 2 plus charge, and chlorine gained 2 electrons, so it's a 2 minus charge. So you would follow these steps for any non-metal and metal and how to draw their ionic bond. And I think that's about it for today's episode. Key takeaways: ionic bonds only happen between a metal and a non-metal. The metal gives an valence electron to the non-metal to complete the non-metal's outer shell, and the metal's valence shell becomes its inner shell, which is already filled. And this would be how you draw an ionic bond, how you represent it for any non-metal and metal. And I'll see you next time in episode number 5, covalent bonding.